my name is Alea, and in this video, we're going to cover water and pH. And so we're continuing on with talking about chemistry. And so in other videos, I talked about the structure of atoms and different types of bonds. So make sure you're familiar with that before watching this video. And so in this video, we're going to cover water, which is a very special molecule for biology. And we're also going to talk about pH at the end of this video. So water, as we've already discussed, contains these hydrogen bonds. Now, why do hydrogen bonds exist? Remember that oxygen and hydrogen, when they bond together, this bond is very polar. Now, because this bond is very polar, the hydrogens are all going to be partially positive, and the oxygens are all going to be partially negative. And because of this, there's going to be tons of attractions between hydrogens and oxygens of separate water molecules. So if we look here, this is one water molecule, but this hydrogen is getting attracted or is attracted to that oxygen, right? That is a different oxygen than the oxygen that it's bonded to. So this is the oxygen that it is bonded to. So they're holding hands, but this hydrogen is looking at another oxygen, right? So it's that meme again of the guy holding hands with his girlfriend but looking at somebody else. And so that's what's happening here, and that's what's happening here. And guess what? When we are looking at a glass of water, for example, there's tons of hydrogen bonding going on all over the place. And so because there are so many hydrogen bonds in water, water has very unique properties that make it very special, and one of the main reasons why it is the most important molecule for living things. And so let's talk about some of these special characteristics of water. So first, water has a very high specific heat capacity. Now, what does this mean? This is the energy required to increase the temperature. Now, water takes a really long time to increase in temperature, or it not really a long time, but it requires a lot of energy. So if you were to, heat up water on your stove, I'm sure you've experienced that it takes forever to heat up water. And so that's going to be really good for living things because most living things are made up of water. And that means that our internal temperature stays relatively stable because water, its temperature stays relatively stable. So, yeah. Another thing sort of related is that water has a high heat of vaporization, which means that it requires a lot of energy to become a gas. So it basically takes a lot of energy to evaporate. And again, going back to cooking, it does take a while to boil water. And so these are kind of hand in hand, but the reason why heat of vaporization is important is because that is why oceans and lakes and rivers exist, right? Because water takes forever to evaporate, we can have a body of water and it doesn't evaporate completely. So that's obviously really helpful for a lot of living things. Water is also a really good solvent. Lots of things like to dissolve in water. Lots of things that are really helpful for living things dissolve in water. And actually, in the next slide, we'll talk about what things do dissolve in water and what things don't dissolve in water. So we'll kind of come back to that. And so things like ions and polar molecules are going to dissolve really easily. And that's kind of what this top diagram is showing is, chloride and sodium when they are ions. So the chloride ion and the sodium ion, because they have a charge, they dissolve well in water. Here's the water dissolving it. And then finally, and I think I'm kind of blocking it, so I'll duck. Water is also very cohesive and adhesive. So cohesive means that water sticks to other water molecules really well, which we already know. But that is really important for living things because it gives water a very high surface tension. So things like this bug can literally walk on water because the surface tension of water is really high. That also makes it so that water, forms droplets and all of that. So just the way that water behaves is because it is cohesive. Now, adhesive means that water likes to stick to other molecules or other surfaces. So water sticks to, for example, the inside of your cup, your glass cup, or the inside of a straw really easily. And so that's one of the main reasons why we can drink through a straw is because we can suck it up and it has all of these adhesive properties. Now, adhesion is really important for living things, particularly for plants, because when plants, like trees, they bring water up through their roots, they need to have adhesion to kind of suck up all the water, kind of like us when we drink from a straw. So if water was not adhesive, then plants would not be able to suck up water. So yeah, those are some of the special characteristics of water. Now let's talk about what does dissolve in water and what doesn't. So there are certain molecules that do dissolve and certain molecules that don't. So hydrophilic molecules do dissolve in water. And these hydrophilic molecules are either going to be polar or charged in some sort of way. So it could be an ion, right? So cations and anions, they are positively and negatively charged. So obviously they're going to dissolve well in water. And then anything that is polar has these polar bonds. So if you have like partial positive and partial negative charges, you're going to mix well with water as well. So water, because it is polar, likes to hang out with other molecules that have some kind of charge. So for example, sugar is a molecule that has a lot of polar bonds. And so it has these partial positive and partial negative charges. And so it will dissolve really well in water. Hydrophobic molecules are going to be these molecules that don't dissolve in water. So nonpolar molecules or molecules that don't have any charge, they just don't mix with water. So for example, oil and water, they just don't mix because oil is very hydrophobic, very nonpolar, doesn't really have that many charges. And so water just doesn't want to hang out with it. All right, so then the last thing we're going to talk about in this video is pH. So when things are dissolved in a solution with water, we can describe those solutions based on their pH. And the pH describes if the solution is an acid or a base. So how acidic or basic something is. Now, if the substance has a pH that is higher than 7, so 7 is our cutoff here. Anything higher than 7 is considered basic. And anything lower than 7 is considered acidic. And then 7 is your neutral. So it's not an acid or a base, it's just neutral. Now, what does this acid base have to do with anything? It has to do with the positive hydrogen ions, which we can discuss in a different video. So for now, just know that higher than 7 is basic, lower than 7 is acidic. That's all you should know. Now the scale for the pH scale is logarithmic. And what that means, I don't want to go into the math too much, but basically what it means is that every, jump from 8 to 7 or 7 to 6 or 6, 7, the jump from one number to another is actually times 10. So in this, example that I put, pH 4 is 10 times more acidic than pH 5, right? So the further down we go, the more acidic we are. Now 5 is acidic and 4 is also acidic, but 4 is 10 times more acidic. So not just 1 times more, but 10 times more acidic. And so that kind of gives you a little bit more perspective as to how acidic that actually is. Okay, so coffee, for example, is pH 5, whereas soda and tomato juice is like 2.5, 3.5, so almost 4. And that is more than 10 times more acidic. So just think about that in perspective. And so lemon juice is all the way down here at 2. That's like 1,000 times more acidic than black coffee, right? So 10, 100, and 1,000, right? Every jump is times 10. So it's a lot. It does get exponentially more acidic as we move down. And then same for the base. If we were to move up, this is 10 times more, and then another 10 times more, and then another 10 times more, right? And it builds. So just to give you some perspective on how much the scale actually jumps. Okay, cool. So that's all I had for this video. Hopefully this was helpful, and I will see you in the next video.